my name is Matthieu Legré. I'm the VP product of SciSec, and I will show you today, let's say, a kind of exploitation of some results from SciSec within the FLUIDOS project. And this exploitation, it's for a use case of confidential computing based hosted private cloud, and that's dedicated to the Italian administrations for the moment. Okay. So I will present this presentation in front of FLUIDOS audience, and the goal is really to explain you how we exploit what we did within the project. I will skip the part, let's say, describing SciSec. That's not what is important, except that the kind of product we are talking, I'm talking about today is Arca Trusted OS. And the kind of, let's say, architecture we worked with looks like what is shown on the on the right side of the screen now. So I guess you are familiar with this. There is a confidential VM, so it's a virtual machine that is that is running in a confidential computing context. The guest OS of this virtual confidential VM is Arca Trusted OS. And so Arca Trusted OS has the capability to request for attestation reports from the CPU, and also had the capability to forward those attestation reports to an attestation service that is running on-prem, so in the on the premises of the end user, and so that the end user can easily verify those, the certificates of those attestation reports, and based on, let's say, the value attested by those reports, to take some actions on it. Okay, so that's the main idea. So it's very, I would say, standard. What is a bit different is the environment. A lot of, let's say, confidential VMs nowadays, they are running in public clouds. In our case, you will see that the goal is really to run on a private cloud, so hosted private clouds. And this is where the ecosystem is not as good, let's say, than what you can find in public clouds. So that was the challenge on our side. So a few words about the use case. So the context is that there is, in Italy, there is an Italian cloud strategy. And the goal is that all the public administration, or most of them, they need to move their IT services, their IT infrastructure on cloud environments within the next, I don't know, but let's say within the next coming years. Okay, so the number is quite impressive because the Italian government wants about 75% of those public administration to migrate towards an environment that they don't use today. And so for this, there are different Italian, let's say, initiatives to create some secure infrastructures for those public administrations. One of the approach is based on a hosted private cloud. So how it looks like? It looks like what we can see on the figure here below. So we will have the public administrations that will be just the end user of an infrastructure as a service provided by a consortium of sovereign Italian organizations or companies. Okay, so this Italian consortium is the host of this infrastructure as a service. Of course, the public administration, they will run their own operations at the VM level, at the operation level, at the data level, and they will operate all the security mechanisms that can apply at the application level and at the VM level. Okay. And the Italian consortium, so the host, will also operate this private cloud as any, let's say, cloud service provider. So they will operate all the operations as a host, And also, they will make sure that the security mechanism that applies or that needs to be applied at the host level, they will manage them. The peculiarity of this, let's say, of this hosted private cloud is that the public administrations, they want to add an extra layer of isolation between the end user and the host. So that's why they want to include confidential computing. And also they want to have a kind of look at what are the security mechanisms that are put in place by the host, so by this Italian consortium. So somehow they want to be able to control and to verify, let's say, that the security mechanism applied by the host, they want to be able to verify that it is compliant with their with the end user security policy. Okay, so that's the use case we want to address. And for your information, we will be in production in the coming months. So normally it will be in production beginning of December for the first private cloud or for the first administration. So we are dealing with sovereign clouds, and to understand or to explain how confidential computing can help in this context, I like to use this representation from Gartner. So they define sovereign cloud as, let's say, a cloud where a customer can come with their own requirements. So they have sovereignty requirements that are applied by the customers, and that will impact 3 domains mainly. So the data sovereignty, the operational sovereignty, and the technological sovereignty. So data sovereignty, it's obvious, it's just to make sure that the data complies with, let's say, the regulations that are in force in the country or in the region where they are processed, where they are generated. Okay, then operational sovereignty means that, in fact, the customer wants to have some control on the operation that are performed by the host to make sure that the security of their VM, of their infrastructure as a service, is as it should be based on their on the customer, let's say, security policy. Technological sovereignty, that's a third topic. It's really about the way that the customer is able to has hands on all the technologies involved in the sovereign cloud. So if we consider confidential computing, because this is what we promote, what SciSec promotes. So obviously, in terms of data sovereignty, what is nice with confidential computing is that you add this extra layer, let's say, of protection of data in use. That's pretty obvious. Then in terms of operational sovereignty, so the control that the customer can get on, let's say, the operations from the host, from the cloud host. In this case, we work on 2 items. One is the attestation of the VM launch, and I will describe later what it is, what we call attestation of VM launch. And then second topic is about a continuous auditing of the VM's instance configuration. In other words, it's to give the possibility to the customer to verify regularly that the confidential confidential computing context of his or her VMs is compliant with their security policies all the time. Okay, so that's the big picture. And in the presentation, I focus mainly on the operational sovereignty aspects. So this is really where we bring more values. And this is where we use, let's say, exploit some of the research within FLUIDOS. Okay, so as I mentioned, there are 2 points we want to cover in terms of operational sovereignty. The first one is attestation of a VM launch. So this means that it's something that is performed at boot time, and to make it short, we want when an end user starts or launch a VM, this end user could have only two possible outcomes: either the VM boots, and in this case, this customer knows that the CC context is valid, the OVMF firmware is valid, the guest OS, so in Arca Trusted OS, is authentic and of integrity, and the VM is authentic. What does it mean? It means that the instance that is booted is indeed the one that is being prepared by the customer. And if one of those four items they are not valid, then the system will just abort the launch or the boot of the VM. So this means that at the end of this process, the customer gets is able to authenticate a trustworthy node in a third-party infrastructure as a service, okay? And it works only at boot time. The second, let's say, aspect that or feature that we propose is a continuous auditing, is the continuous auditing of the VM instance. So it's at runtime, so when the instance is running, this instance, or let's say some agent within this VM instance will request regularly for attestation reports to the CPU and forwards them to the customer. And then the customer will be able to verify if let's say the value provided by this attestation report, if they are valid or not compared to the security policy. So that's a way, let's say, it's a technical way to verify the compliance of a legal agreement, let's say, between the host and the user. In this case, the user can verify the confidential computing context with a third party, which is a trusted third party, which is the CPU itself. Okay. So now a few words about Arca Trusted OS to understand how we implement those features. So Arca Trusted OS, it's a micro distribution. It's with an immutable file system. We have a full disencryption of the user space. Let's say it's by default, and this is something important. The root file system, when we don't use confidential computing, so there is no confidential VMs in this slide. So the root of trust in this case are the OVMF provided by the host, by the CSP, and the VTPM. Also, it's a piece of software provided by the host. The secure boot chain, it's a basic, let's say, secure boot. And as I mentioned, we have this approach to either we have a successful secure boot and, okay, we boot the system, or the secure boot is not successful and we just abort the system. There is no way, let's say, to bypass the secure boot. In the cloud, of course, we rely on the CPU, on the OVMF, and the VTPM for the root of trust. So this means that in terms of element that the end user needs to trust, there is the CPU, the OVMF, and the VTPM. And so now, if we work with confidential VMs, the goal is really to change this trust model. So we still have Arca Trusted OS. As I mentioned in the first slide, we have also an attestation service that we provide that is running on-prem. It's operated by the end user. And with this, so we call it the verifier. There is a way to verify, of course, the attestation report, to deliver some and to store some encryption keys that are used, in fact, to unlock the full disk encryption of the Arca Trusted OS user space. There is the possibility to define some security policies and to take actions, let's say, depending on the let's say what we retrieve, or what the system retrieves in the report, attestation report, sorry. And there is also the capability to generate some security events based on the attestation reports. So in Arca Trusted OS, the only point that is different is that we have an agent within Arca Trusted OS able to request for attestation reports. And in the cloud, now we use the CPU. So this is for the private clouds. We use a patch OVMF with our own secure boot key that is hard-coded. This is extremely important, let's say, to bootstrap the secure boot of Arca Trusted OS with the chain of trust that we can build with the attestation reports. And then there are all those confidential computing, let's say, capabilities with the secure processor, data confidentiality protection, OVMF integrity verification, and those attestation reports provided by the CPU. Okay, and so with all those elements, with all those functionalities, we developed two protocols. One which is called attestation of a VM launch, and the other one which is this VM instance auditing. So this is what we do. It's really building a solution with those elements, some coming from Arca Trusted OS or SISEC verifier, some other ones coming from the CPU and from the cloud. Okay, and we reduce, with this approach, we reduce the trust model to the CPU and to the secure processor. Let's say, in short, we trust all the, let's say, the confidential computing mechanism offered by the CPU, and based on this, we build our solution. Okay, and now I will continue with the attestation, the attestation of the launch of a VM. So that's the kind of threat model that we consider. So that's the VM, that's the confidential VM that we consider. There is a client side or an agent. There is the host hypervisor with the VTPM or VMF that we don't use. There is this AMD, in our case, we use AMD CVSMP, so AMD platform, a security processor with some firmware. And there are some other players on the same cloud, some other, let's say, legacy VMs, some other confidential VMs that are not related. And we, let's say, consider a threat model where a threat agent can be, okay, outside the confidential VM and try to attack, for example, the agent, or attack the remote attestation service, for example. But we consider also in our trust model the case where an attacker has been able to take control of an application, for example, in the confidential VM, and then try to take control of the agent to get, for example, secret keys from other VMs, okay? So that's the kind of threat model that we have in mind. And based on this, we build a protocol that looks like this. So it's a high-level vision, let's say, of the protocol. So first, you need to imagine that, okay, we are at this step. So the customer provides to the host piece of software plus configurations. And so the configurations and the piece of software, they are provided to the host, and the customer says, okay, I would like you to launch my VM with those pieces of software and those configurations. And then there is the launch of the VM. So from the customer perspective, the customer can see, okay, the start of the OVMF. Then there is the start of the bootloader, kernel bundle. And then at some point, we reach the step where Arca Trusted OS is launching and running the init from FS. And this is where we stop, let's say, the process of the boot process, and we start this interaction between, let's say, the agent, the local agent, the secure processor, and the remote attestation service. This interaction looks like this. So you see on the left part, there is the VM guest or VM agent. on the right part, there is the verifier. So this is what happens on on the premises of the end user. And we get a process that goes in 3 steps. So we have 3 steps of challenge and response. After the first step, what we want to be able to do is to establish an unidirectionally authenticated TLS channel between the agent and the verifier. So why directionally authenticated? It's because the guest, so all those pieces of software in Arca Trusted OS are in clear. So this means that there is no way to, let's say, to put any secret, or at least secret that cannot be seen by the host of the cloud. So that's why let's say the VM agent is able, with a public key of the verifier, to authenticate the verifier. But at that stage, the verifier is not able to authenticate the VM agent. The only thing that the verifier knows is that the VM agent has an ID that is, let's say, already registered somewhere in a database. Okay. Then there is the second challenge step. And this is, okay, when the verifier sends an announce to the VM agent will request attestation report to the CPU with the announce, so to get a fresh one, send this attestation report to the verifier. Verifier will verify, okay, first the validity of the attestation report, and then the validity of the values. And then at the end of this process, the verifier knows that it is talking with an authentic Arca Trusted OS, okay, based on a fresh attestation report. So this means that all the pieces of software, OVMF, bootloader, kernel bundle, and initramfs, the verifier knows that they are of integrity. But still, at this stage, the verifier doesn't know if it is talking to one Arca Trusted OS or the one it prepared before. And the preparation step goes with the encryption of with the disk encryption. So this disk encryption can be done on-prem. And when there is then disk encryption, there is a key storage where, okay, the key is stored and associated with an ID that, in the case of SEV SNP technology, we associate it with a field that is called host data, and that can be attested by the attestation report. Okay, so the third and last challenge response step, is that the verifier will send the encryption key or the decryption key to the initramfs, to the VM agent. And if the agent is able to decrypt the disk, then we will, let's say, Arca Trusted OS will boot till the end. If the VM agent is not able to decrypt the disk, the process will be aborted. So we of course, the agent will just withdraw the key properly and then abort the boot process. Okay, that's how it works. And so some takeaways to conclude this presentation. There are 3 points that are important. So first, confidential computing technologies, now they are under deployment within project of hosted private sovereign clouds, okay? And that's pretty new because I'm talking about private clouds and not public clouds, where, let's say, confidential computing is present for now several years. Confidential computing can contribute to operational sovereignty, but by allowing cloud users to enforce and audit applications, so to gain control on what the infrastructure as a service provider do, in fact. And the last point is that confidential computing related products for private cloud, they are still limited for the moment. And so we expect that with this kind of use case, the ecosystem will grow. And for example, we are presently in discussion with VMware, for example, to make sure that they go in the direction to adopt SCV SMP. Okay, so that's the end of my presentation. I guess we can stop the recording.